Gold. It's fascinated us humans for thousands of years. It permeates our myths. Empires and economies have been built and destroyed by it. And today, it plays a key role in our most advanced technologies.
But until very recently, we didn't actually know how gold is made. For centuries, alchemists like Newton had devoted years of their life in search of the philosopher's stone, this mythical substance that could turn base metals into gold. And they believed that the truth lay somewhere in their scrolls and in their flasks. But they were way off the mark. And the true process was finally theorised in 1957. But for decades, we had no proof. All that changed just a few years ago, and on August 17th, 2017, while probably many of you are still asleep, we were visited by two messengers from across the stars who finally delivered the evidence. And this video is about that cosmic treasure hunt.
The story culminates on August the 17th, 2017, but it actually begins over a century earlier with this man, Albert Einstein. Not as he is here, arriving in America in 1933, but as a young man in 1916, reshaping our understanding of the universe with one groundbreaking idea after another.
One of the most profound predictions that was a direct consequence of his theory of general relativity was that of gravitational waves. And these are ripples in space-time, so compressions and stretches in the fabric of space-time itself that are generated when massive objects move around each other. A further prediction was that gravitational waves should move out from their source very precisely at the speed of light. So something that's not light, but still moves at the speed of light. Hypothetically, it should be possible to detect these waves, but Einstein knew that it would be almost impossibly difficult. And in fact, he wrote, "The energy radiated by gravitational waves is extraordinarily small unless very large masses are moved at very high speeds." By the mid-20th century, it became clear that there were only a few cosmic candidates that might generate gravitational waves strong enough for us to be able to detect here on Earth. And among those were black holes and neutron stars spinning around each other. And neutron stars being the dead remnants of particular sorts of stars where the mass is so compressed and so dense that if our sun were to be transformed into a neutron star, all of its mass would be compressed into a sphere only about 10 miles across. Remember neutron stars. They become key players in our story in just a few minutes.
In theory, it should be possible to detect the stretching and compressing of space-time caused by these extraordinarily violent events. The idea was to use interferometers, massive L-shaped detectors with laser beams bouncing between mirrors along vacuum tubes at right angles to each other. If a gravitational wave passed through, it would create an almost imperceptible difference in the length of the beams as space-time itself stretched and compressed. But the changes we would expect to detect are incredibly tiny. We're talking about distortions smaller than 1,000th of the diameter of a proton.
And yet, in 2015, some of the world's finest scientists and engineers achieved just that. They built two interferometers in the United States, and for the very first time, were able to detect the gravitational waves generated by two black holes crashing into each other. I mean, it's an achievement that's nothing short of heroic. And it marks the arrival of a new messenger, gravitational waves, that can now tell us about the cosmos. One of the many beautiful things about this story is that the frequency of the gravitational waves as the objects spin around each other can be turned into a sound. And as the objects get closer and spin faster, the pitch rises until they crash into each other. And what you're left with is a chirp. The universe has been chirping for billions of years.
In 1957, scientists had another incredible insight. They realized that when two neutron stars collide, they create the perfect conditions for something called the R process, or rapid neutron capture process. And this is the process responsible for creating the heaviest elements in the universe, including gold. The moment of collision is known as a kilonova,
and is an event so violent that for a few moments, many times more energy is released than from the entire rest of the universe. And included in this, we would not only predict gravitational waves, but also truly massive amounts of electromagnetic radiation would be blasted out across the cosmos, including the highest energy gamma rays. But that's only the beginning. Over the next hours and days, the R process unfolds, where streams of high-energy neutrons bombard the atomic nuclei, forcing them to become heavier and more unstable, and they then undergo beta decay, where the neutrons are transformed into protons and electrons, and light is emitted as they stabilize into heavier elements. And what you're left with are the nuclei of heavier elements like platinum and gold. So all you would need to do to confirm that gold was being created would be to wait for a gravitational wave to pass through the Earth from that fleeting moment where two neutron stars are smashing into each other, point your telescopes to where they are, and wait to collect those photons, those light particles, from the R process unfolding. But where would you know where to look? The method that your phone uses in its GPS is called triangulation, where it takes signals from at least 3 satellites to triangulate, to calculate its position, your position, on the surface of the Earth. And in theory, you could use an analogous method to triangulate the source of a gravitational wave as it ripples through the Earth at the speed of light, triggering interferometers as it did so. But for this to work, you would need at least 3 interferometers. By an extraordinary stroke of luck, the third interferometer, Virgo, came online in Italy at the beginning of August 2017, and our cosmic GPS was up and running. Just a few weeks after Virgo became fully operational, it picked up the telltale signal, a chirp. And 22 milliseconds later, LIGO Livingston picked up the signal, and Hanford a couple of milliseconds after that. And under 2 seconds later, a huge gamma ray burst triggered the Fermi detector. So, gravitational waves and photons, the two messengers signalling a kilonova. The race was on to find the source. The triangulation data from the interferometers gave an idea of where to look, and this coincided with the area of sky where the gamma ray burst came from. This was immediately communicated to observatories across the world and in space, including the Hubble Space Telescope, saying, "Look here!" And incredibly, after just a few hours of this concerted effort, a new light source was detected in a galaxy 130 million light years away in the constellation of Hydra. We had found it. I mean, just think about that for a moment. These two utterly different messengers, gravitational waves and light, set off on their journey towards us 130 million years ago. 130 million years ago, when dinosaurs were roaming around where I'm sitting right now. And they both arrived on the Earth within a few moments of each other. I mean, it's just mind-boggling. Miraculous even. I mean, what a validation of an idea. Once the object had been found, many other telescopes turned towards it and started collecting the photons from the kilonova. And this is where we found the treasure. As the kilonova settled after the cataclysmic collision, the fingerprints of the R process. These photons in the spectral data confirmed that this was indeed where the heaviest elements, including gold, were being created, right in front of our eyes. It's been estimated that about 10 to 20 Earth masses of gold were created in this kilonova over 100 million years ago. I mean, it's just extraordinary. Not only that this is how it happens, but also of how we know that this is how it happens. The gold in this chain, the gold in that ring on your finger, the gold in all the treasure in all the world. It was all created billions of years ago in our little patch of the cosmos by the unimaginably violent collisions of neutron stars. And the remarkable thing is, this is just the beginning. The universe is still creating. Right now, neutron stars are spiraling towards each other, and their collision will send out more gravitational waves, creating more gold, platinum, and other heavy elements. And each time we detect one of these events, we learn a little more about the cosmos and our place in it. And it's not just a story about cosmic alchemy. It's really one about human ingenuity and perseverance and collaboration, which I think is far more valuable than the gold itself. Thanks so much for watching the video. And if you enjoyed this, I strongly urge you, I would love you to watch the press conference from 2017 where multi-messenger astronomy was announced. So where the first gravitational waves and photons detection was announced from the in-spiral of these neutron stars. And I would have loved to have been in the audience. It's a press conference. It's so full of excitement and joy, and it's uplifting. And yeah, I would love you to watch that. I'll leave a link in the description below. And if you like this, then do subscribe for more. I'd love to make more content like this. And I'll see you in the next one. Bye bye.